we're going to take a look at how to determine missing angles. So as you can see, we have a right triangle, and I'm trying to find out what that angle is. Now we're going to go back and use the SOHCAHTOA, a really important concept because it can do all kinds of cool stuff for us. So I've got the opposite, right? Remember, we can go ahead and do that. We'll label them, right? So we'll say, all right, here's H for hypotenuse. Our angle, so the 11, that must be the opposite. And then that makes the 8 the adjacent. In this case, I've got the opposite and I've got the adjacent. So if I take a look at my different functions, I've got opposite and adjacent. Can't use that one. Can't use that one. I can, though, use the tangent. So I'm going to say tangent. We know it equals opposite over adjacent. When we're trying to find an angle, though, we're going to use an inverse tangent. So we'll say tangent -1 equals opposite, which in this case happens to be 11, and our adjacent, that number happens to be 8. So what we'll do is we'll put that in our calculator, and that'll tell us the exact angle. And when I put that in my calculator, I get an angle here of 53.973. So that's what's going to go there. That's our missing angle. Now, likewise, we could have done it differently, too. We could have said, all right, you know what? Our angle happens to be this one. We're missing that one. How can I solve for that? So the labels become a little bit different when I do it this way, right? The hypotenuse is still the same, but now this side becomes the opposite, and this side becomes the adjacent. And again, I can actually use the same tangent formula, right? So I can say tangent of -1, so the inverse, without changes a little bit. So this is going to say 8 over 11, because 11 is the adjacent. Plug that in my calculator, and when I do, I get an angle up here of about, let's see, 36.027. All right, so now if I would add it up, because remember this one's 90. So if I add these up, so the 36.027 plus 53.973, that's 90, plus 90 more, that gives me 180, right? And we know that those triangles should always add up to 180. There's always 180 degrees in there. All right, so let's take a look at one more here. Let's say I want to do this. So I'm trying to find this missing angle. And this time we've got a hypotenuse. Let's say that this is 21. And we'll go ahead and do this adjacent over here. Let's go ahead and make this, I don't know, let's go with 11 there. So again, we're going to use SOHCAHTOA, and I will go ahead and come over here and label it. So right here, there's my angle I'm trying to find. So that makes, this is the opposite. We always know the hypotenuse, right? So there that is. That makes this the adjacent. All right, so now we can look and see what kind of functions. I have the hypotenuse, so I need something with an h in it. So that immediately takes out tangent, right? So I need either sine or cosine. I don't have the opposite, so sine's not going to work. So it looks like I'm going to use cosine. So there's that formula. Cosine equals adjacent over hypotenuse. So we're going to set it up the same way. So the inverse of cosine equals adjacent, which in this case is 11, over hypotenuse, which is 21. All right, so I'll punch the same thing into my calculator. My angle comes out to be 58.412. Right, so you can see SOHCAHTOA has a lot of practical applications to it. It's not just about determining lengths of sides, although we can, right? But we can also determine the angle size.